satellite is highly dependent upon the gravity field of the planet that it's orbiting. So what we wanted to do was put up a satellite whose orbit we could measure incredibly accurately. The best way to do that was to observe one satellite with another satellite. So the satellites are sort of chasing each other, pole to pole, flying around the Earth. And as the first one comes up, for example, on a mountain, it feels that mountain first. So it starts to get pulled toward the mountain. But the second one isn't quite there yet, so the satellites tend to sort of drift apart. Then, of course, as they're leaving the mountain, the second one is still feeling the effect of the mountain. So they come together again. And that sort of dance that the two satellites do as they go around the Earth is what tells us what the gravity field underneath them was. Now, in addition to that, the gravity field is also changing every day, every week, every month, because water is moving all around the Earth and it's raining here or the polar ice cap is melting. So water is the primary thing that's changing. But what scientists really want to understand is not just what happens across 1 year. They want to really see that play out over many years, over decades, to try to understand what's really happening in the climate system.
We know that the world's distribution of water is being affected by climate change. One of the key things that GRACE data does is help us to monitor where the water is now and how it's changing over time. Before GRACE, it was nearly impossible to get that measurement. We would have to set up just an incredible array of equipment and an army of dedicated students and volunteers working several hours a day, a few times a week, year-round. And that wouldn't even be enough. GRACE is allowing us to see for the first time how fresh water is being redistributed across the continents. So here are the GRACE data. So what GRACE really does is make a map like this once a month, and the blue areas are areas that are wetter than usual, and the red areas are areas that are drier than usual. If the whole map were green, that would imply no storage change, so that would imply sort of a steady state. And for a long time, that's what people thought. And a lot of engineering and a lot of our infrastructure, storm drains, bridges, were built based on the idea that there were no long-term trends. And what GRACE is showing us is that there are these trends, that there are in fact storage changes, and that we have to deal with the changes. Let me point some of them out to you. Some of the biggest signals are the ice sheets, Greenland and Antarctic ice sheets that are melting away at a steady pace because of climate change. Some of the things we're really just starting to learn about are the decline of snow water storage in the Tibetan Plateau. That's a region that feeds many of the world's major rivers. We have the annual oscillation. We also have a trend, and that is an area where the trend is a linear decline. This is the Murray-Darling Basin in Australia. This is a basin that supplies a huge amount of water to the people of Australia. It's where most of their water resources are developed. And for as long as we've been looking at the GRACE data, that basin has been losing water. And it is not a good situation for the people of Australia. A surprise that we get from the GRACE data is that we're able to see groundwater mining, where groundwater is being removed from subsurface aquifers at a rate that's greater than it's being naturally replenished. One place where there is active groundwater mining is in the High Plains aquifer. Water levels have been in steady decline there for about 50 years. There's something like 1 billion people in the world today that don't have access to clean water. We need to be able to manage it. We need to be able to allocate it in ways that are consistent with climate change. And so GRACE can really help us track the distribution of water to help us better predict how climate and water availability is going to change in the future.
With GRACE, we have a new way to measure these things that scientists have been looking for so long. How much water is in the ocean, how much does the polar cap weigh, how much did it rain in the Amazon this year? You know, things that you think of as being very gut feel physical measurements that turn out to just be hard to make any other way.